Hello, my name is Clayton Kawasaki, and I'll be speaking on behalf of our senior projects group. So I'll introduce you to our members really quick. Our first member is our team leader. His name is Eldon Posey. He organized our submissions. He came up with the mission statement, oversaw the design, and oversaw the reports. Our next member is Adriana Panado. She helped in the design, CAD modeling, assisted in the measurements, and also helped in the reports. After that, we have James Myers. He did our bill of materials. He picked the parts, oversaw all the design constraints. And then we have I myself, Clayton Kawasaki, and I did the 3D model, the calculations for those parts, and also oversaw the final decisions on the design of our project. So we were in charge of designing grapple, and this grapple was going to be used in the mission field. Um, and It would be used in disaster relief, either cleaning up after a disaster or doing construction after a disaster. Our customer's needs is he needed it to be lightweight, he needed it to be cheap, he needed to be able to. One of his main needs was that he needed the grapple to be able to open and close, whether the scoop was facing downwards, sideways, or up. He still wants the grapple to be able to move open and closed. Um, and those are some of the customer's needs for this grapple. So we decided to come up with a rough estimate on what we were up against. We used Creo Parametric, which is a 3D CAD modeling software to allow us to make any changes as we go along and not have to redo the whole thing. So we started off with a rough draft, and in the beginning it was way too big, it was way too heavy, and it would have cost way too much. But when Adriana finally got back with us on the final measurements, we were able to reduce it down to the right dimensions and actually build it well within our price range, and it was less than 150 pounds of material. So another thing that we had to consider was how we were going to build the grapple. Um, on my first design, I had it with threaded holes, that way we can bolt it together, but we realized that we were going to build this ourselves, and none of us knew how to do that. So I designed it to the with material that we can just order with the correct width and thickness, and all we would have to do is use a blowtorch to cut it up and a welder to weld it together, a MIG welder specifically, to make it even easier. That way it'd be easy for us to assemble it together after we ordered all the parts. Um, Another thing was how we were going to mount it. We had to decide as a group. There was a wide variety of ideas we could go about mounting it to the scoop. We decided to just weld pins onto the scoop and mount it to that. Another thing that we had to decide as a group was the actuator, because the customer needed this grapple to operate at any angle the scoop would be at. We couldn't just mount the other end of the actuator to the tractor, because the scoop might be facing downwards, and that just wouldn't work. So we decided to mount the other end of the actuator directly to the scoop that the grapple was going to be on. That way the actuator could still operate the grapple at any angle the scoop would be at to allow us to achieve those customers' needs. So that was another big decision that we had to come up with as a group. We also needed to make a decision matrix to figure out whether we were going to go with an electronic actuator or a hydraulic actuator. Within this, we realized that the electronic actuator was going to be too slow and too expensive, so we stuck with the hydraulic actuator, which actually produces more power, was a lot quicker, and only cost $200. We were able to find a whole assembly with the motor, the pump, the solenoid, the tank for only $200. We were able to figure out our hydraulic actuator. We used Creo Parametric and figured out the 2 points from where the hydraulic would be mounted on the grapple and the scoop. And we realized that it would only be traveling 5 inches to fully open and close it. So we were able to find a hydraulic actuator that was 11 inches long, would shrink down to 6 inches and travel 5 inches, with a 1-inch bore to allow us to achieve the amount of pressure needed to create the force to move it, and also allow it to travel at a very decent speed. I think within fully opening and fully closing it, it would only take 15 seconds to open and close it, which saves the customer a lot of time in operation. So we one of the constraints we had was making sure that it was going to be affordable and lightweight. In the end, it had to be less than, I think, 700 pounds, and we were able to get it within 250 pounds with the grapple, the hoses, the actuator, and the pump all together. We were able to get it under 1,200 bucks. I think the entire grapple assembly with all of the parts included was just under $900. Um, so we were able to finalize our design with Eldon. After that, he did some research on other competitive designs, and the way I had it initially designed, I had the grapple with the fingers facing outwards, but Eldon said that according to his research, John Deere had a lot of their fingers on their grapples facing inwards, which actually makes better sense because if the grapple's coming down onto something or scooping up something, you want the grapples facing inwards to push everything in towards the scoop. And so Eldon was able to get with me on an angle on that, and I was able to change the fingers instead of outwards, inwards on the grapple to allow us to achieve that design. Um, so that kind of finalizes our overall design on the grapple. We were able to figure out how we were going to get it to move and pick out our actuators, our pumps, uh, and figure out all of the hoses and the adapters needed to connect our actuators to the pump. And as industrial engineers, safety was also important to our group. So one of the things that we had to consider was ergonomics. How easy was it to use, and how safe was it to use? And so in between this solenoid operating the motor and the switch, we ran a really long cable through it. That way, the operator can not only sit from the tractor and operate the grapple, but also get off of the tractor and also stand with the grapple and actually see what the grapple is doing. If anybody's in the way or if anything's getting pinched, he's standing right there to see it. He can easily just turn the switch the other direction, and the grapple will open back up. So that will allow for ease of operation and safety considerations on our grapple. Um, so for our goals met, we were able to achieve it within the correct weight. We were able to achieve it within the correct price range. We added to where it would actually operate at any angle to allow the customer to scoop stuff off the ground, but also maybe lift something up or grab something out of a tree. It would do everything that the customer needed it to do. Um, and we would also like to thank Kevin. He assisted us in some of the machining aspects needed to design this grapple. He gave us some assistance on how to go about designing it for the machining aspects, and he also would have been the one to order all of our applications, but due to the coronavirus, we won't be able to order it and assemble it together. But we do want to give a shout out to Kevin for helping us with a lot of the big decisions on this project. So thank you very much.